Hello friends, today we will be solving a problem related to synchronous machine, and it says there is a three-phase stator winding which has 9 slots per pole and it employs 10 turn coils with a coil span of 7 slots, and the EMF induced in each conductor is sinusoidal and its RMS value is 8 volts. Then is asking the RMS voltage induced in each coil. Okay, so you can see here that the coil spans only 7 slots, but the winding has 9 slots per pole. Okay, hence the coil is a short pitch coil, it's not a full pitched coil. Okay, so we have to take that in our mind before proceeding for this question. So how to proceed here is, first what we'll do is we'll try to calculate the voltage induced if it was a full pitched coil, and then we will multiply it with the winding factor, which is here only the pitch factor. Okay, so if we multiply with the pitch factor, then we get the voltage induced in the coil. Okay, so let us proceed. So here each coil has 10 number of turns. Okay, and each conductor has 8 volts of induced voltage. Okay, so if you look at this coil, okay, if it is a full pitched coil, then the voltage induced here say is some x volts. Okay, then the voltage induced in the other side of the coil, okay, on the slot, say this is the slot first and this is the slot 9. On the 9th slot it would be the same voltage but with opposite polarity. Okay, so these two will have a 180-degree phase difference. Okay, so if you want to know what is the voltage between A and B, then this voltage will be just added up. Okay, it will become 2x. Okay, so say each conductor has 8 volts, so each turn will have 16 volts. Okay, so voltage induced per turn, turn will be 8 into 2 is equal to 16 volts, but the coil has 10 turns, so voltage induced is equal to voltage induced in coil is equal to 10 into 16. Now this is 160 volts. Now this is the voltage induced if it was a full pitch coil. Okay, so now what we need to find is the voltage induced, because we have a short pitched coil. Okay, now you know that by how many slots it is short pitched. It is short pitched by 2. 9 minus 2 is equal to 2 slot. 9 minus 7 is equal to 2 slots. Okay, so it is short pitched by 2 slots because the coil only spans for 7 slots, and but there are 9 slots per pole, so 9 minus 7 means 2 slots. Okay, now once we have that information, what we can do is we can notice one thing, that 9 slots will correspond to 180-degree of phase difference, as I explained earlier. Okay, because it's a full pitch coil, so at every 9 two conductors which are 9 slots apart will have a phase difference of 180 degrees. Okay, so one slot will have a phase difference of 180 by 9, and two slots will have a phase difference of 180 by 9 into 2, and if you can calculate this comes out to be 40 degrees. Okay, so we now know that the coil is short pitched by 40 degrees. Okay, so now we can calculate the pitch factor. Okay, so now the pitch factor is equal to cos alpha by 2. Okay, so that angle alpha is equal to 40 degrees is the angle that we need here. So it is cos 40 degrees by 2, so it will be cos 20 degrees. So now the voltage induced will be okay, the voltage that we calculated for the full pitch coil, which was 160 volts, into this factor, which is cos 20 degrees, and if you calculate this comes out to be 150.35 volts. Okay, and it matches with option A, so A is the correct option. Okay, so this is how you need to solve this problem. So thanks for watching.